Right, one more part finished. This part will be welded inside that. I have to bore a hole through this, suit that, and then that will be put in through the hole and welded on one side, on the back side there. And then I'll machine the front again to straighten it up to that, because the welding might distort it a bit. Getting there slowly, and I'll have to still do that repair. Where is it? There it is. I'm not sure if the 2mm end mill is going to go do this. Bit of luck. That's a real bit of bugger. We could probably leave it out, but I want to get it out. The thing is, it's getting weighty, so I'm not sure if the little 9mm pistons are going to cut it. We can always change them, I guess, but then that increases the weight, and then I'll have to make out, if I make them larger, I'm going to have to make rings. Probably needs rings anyway, might blind up, not sure, we'll see how it goes. Okay, that's a nice tap-in fit, if it's bored straight. I'm not sure if I should open it up a bit more. It would probably tap in. Maybe a shaving, just make sure it goes in easier. I gave it 1/100th of a millimeter extra, much better. Still pretty tight, it shouldn't distort too much, but it can look, it's not quite in the full depth. Probably should have left it. We can twist millimeter. But I reckon if I bang it in there, it probably will be not too bad. I got plenty to shave off here if I need to. Doesn't have to be this thick. Alright, another component finished. I reckon the next step is to set up the milling machine attachment and work on this. And then I'm going to take out 5mm from each end down to about 5mm as well, so the bolts can sit down lower. I need to drill a hole down there and through the center. Center's marked. Oh, and face the top maybe, or maybe not. It's not important, is it? I might. Oh, back today, just gave that a weld, let it air cool, so I didn't introduce some stresses of chilling it. So I'll attach that back to the face and then machine this face here, and once that's done I'll put it hard up in the chuck there and just clean up around here a bit. It won't take too much of the weld off. I only need the edges done really. And then that should finish that part of the job off. Then it will be setting up the milling table. It has a slight bit of wobble. But it's not too far out. It looks pretty good there actually. I'll just face the end off. So I set it up with the parallels. The magnets hold the parallels perfectly apart for this job anyway. And you should be able to just slide them out. And we should be pretty true. I need my magnets now because this thing hits. I should have made it slightly higher. So I'll set that up and then we'll see how true this looks. Okay, it doesn't look too bad spinning there. That's at 810 RPM. So I'll just surface about 6 mil in or so, just around that lip, just to clean up that rust. Looking fairly true. If I just can you see that? My eyesight can't see the difference in gaps. We could zoom in. So at least it distorted pretty evenly, if it distorted at all. I'll face that off. And then I can attach that's the machining for now, or using the lathe, and I just need to get that broken tap out of that bit with the end mill. It's going to take like a couple of hours to set up the mill, just to true it in. Very tricky. So I just took the bare minimum off it. Or this may interfere, the weld may interfere with the crankshaft if we make it too proud. I think there's about 3 to 4 mil between the crankshaft and this face. Oh yeah, we're all set up, ready to tackle this drill tap, or I should say threading tap. I think we're pretty much lined up. It's really hard to see. I'll just check it one more time. I think the best way to line this up was to stick the drilling template back in. Okay, we're totally lined up now. All I have to do is back it out, pull out the 2mm drill and get rid of that. camera to see it. Got a little bit more to go. I think that's it. I can feel something there still. That might be rubbing on that shoulder. See that vibration? Oh, that actually cut through there. Quite good. I'm going to have to probably chisel out some of the stuff. I reckon it'll be clean. Let's go for a look. Oh, we're zoomed in too much. Where are we? Oh, come on, focus. Yeah, I'm gonna have to probably scrape some or bang it out or something. Or maybe not. Alright, I'll get it out and let's see it. There's a little shard left. I put it in the drill, but I got the shard out, but the end mill broke as well. And the hole's slightly oversized now. So I could probably go for a 3mm bolt for that one. Or I could drill it out and put a sleeve in and then flush it off. I'll think about it. But that worked. That was but sacrificed $8 for this little beast. Tungsten carbide it was. That's alright, I'll have a piece of tungsten carbide for a scraper. So 2 taps broken and a tungsten carbide. I think before I drill it out larger, I'll make some GB weld up and squash it down into the hole and pack it properly and see if I can refix it. It says it's strong enough to be tapped, as long as it's not too strong. Okay, so I've repaired the hole. I've drilled and tapped it already. I'm now ready to drill the 5 steam ports inlets in the basin into this part. They line up with the centers of these. I've got the chuck. This is an overkill chuck. It's too long for the size of this. It's ridiculous. When it's in the tailstock of the lathe, it waves up and down because it's too heavy and sticks out too much. It needs to be only like this much. Maybe I can change the head one day, or just buy a whole new piece. Oh, okay, I got that centered anyway. That's a 4mm hole. Should fit snugly in there. It has to be silver soldered in. That's going to cost a little piece of money, the silver solder stick. Don't need much, but got to buy a length of it. Alright, I'll get these drilled out and cleaned up. And the next job will be just a light skimming over the top of these, just to face them off. A fly cutter, I reckon. I'll have to stick the lid on so I can get the surfaces all cleaned up properly. Just enough clearance to drill with this setup. I had to go right back there because of the chuck is so long. It's like, where's the rule? Yeah, it's 100 millimeters long. Yeah, I've got the sides fly cutted, but some of them won't clean up because I was a bit heavy-handed with the grinding. It's not important down there. Just the center holes, as long as they're cleaned up at the top centers. That one was heavy-handed over here. We're only talking about a little bit, but enough for the surfacing. Well, that was a big one though. That was a, don't know what I was thinking there when I was grinding the welds off. So I have the 5 holes also drilled. I've got to clean them up now and clean up all this. Where's the repair? There it is. You can sort of see the JB weld there. It's a grey looking, it's this hole. And that little notch didn't, I could probably, I don't want to take it too thin because of these bolt holes around the outside. There's not a lot of meat there. If I was going to make another one of these, I'd scale it up a bit bigger. So all these would be 5mm holes, and those larger pistons. Probably go, I don't know, good hand size. Big enough just so I can still do it in the mini lathe. Fly cutter I used. I should have got a round inset. It would have been probably a lot smoother. I'm not sure if it's my technique of feeding too fast. It's flat, but it's a bit rough looking. And I can't go past, what is it, 460, or it starts shaking. It's too heavy. Maybe I could move this in slightly. It's more balanced. But yeah, it starts wobbling the whole table, which is like an 80-kilo table. Cleaning up the cylinder heads with the fly cutter. You can sort of see it wobbling at that 480 RPM. I think that's a center pump. talk about. There we go, got 4 others to clean up now. That looks good. That's 5 cylinder heads surfaced. Next step is to open up part of that hole to take this Allen head, and it only needs to go down to around about there, and then I have to end mill a section off each side. I could leave it like that, but I'm reducing the weight by cutting out that corner. But I can't go too deep into there, that's why I'm doing this 4.5mm hole to suit the head first. That will give it a little radius in there, and I don't have to end mill it right off to the full depth. Because we need a 4mm hole in the center for the steam tube. So they turned up alright. Still got some scratches. That's my feeding rate, I think. And speed maybe. Too fast, too slow. I can't go any faster, so I'll have to go back it off a bit. Auto feed might help with this, but I don't have anything set up yet. Getting there slowly, one step at a time. Having a closer look at the setup, it only has to go down as far as that head is wide, or the depth of it, and 4.5 doesn't quite fit around this, so it'd have to be the next size up, which is 5mm, so I might as well just cut a 5mm groove right down the end on both sides and be done with it. Much simpler than worrying about setting it up in the drill press and drilling that down to that size. Having it just there like this takes this to the bottom of the blocks, little surfaces right at the bottom. We can't have the bolt protruding down into the crankcase. It'll interfere with the crank and stuff. I have a set up tungsten carbide, 12mm end mill. It only has to be 2.5mm deep and 5mm down. I'm wondering if I can cut that in one sort of pass. I've seen YouTube people cut deep, but I don't know if the mini lathe can do this in one go. Well, I'll try, see what happens. Don't want to break my end mill though, I'll go slowly. Okay, trying 2.5mm deep and 5 down. think it cut pretty well. I might turn the speed down. That was at 800 RPM. Yeah, perfect. Alright. I was wearing my shield. Don't want that thing flinging out my face. Now, did it get hot? No, it was alright, it's cool. Still good. There you go. So, that's still not too bad. I wouldn't want to go any deeper in a larger cut like that. It was squealing a little bit. Now I'll just have to lift it up and cut the bottom section. Or should I flip it over and do it the same way I did it? Probably not. I'm still new, I'm not sure which way I should travel underneath. It's gonna spin this way. So we'll cut into the job. I'll have to feed it this way if I'm under. Is it? Chomp, chomp, chomp. Yeah, I'll have to feed that way. I'll have a think about it. Well, the first way I was cutting, I think it was primary, so I'm pulling the workpiece this way with the tool spins that way. And now this will be conventional milling, and that feels a lot better for the machine. I've gone in nearly half of the cutting bit already. And you can hear the difference in that once I start engaging the cut. I think this is the better way to cut for the hand mill. RPMs are 720. Nice and smooth with that one. lot better doing it that way. The other way was getting pretty intense feelings. I was. Yeah, I think I'll be cutting that way from now on. It's much safer. Feels safer. The cylinder heads turned out okay. Got them all machined up and drilled the steam inlets. Next task is to bore out that little hole in the piston. To do that, I've got this 3mm end mill. The con rod's 3mm wide. It should be just enough clearance. Then I have to drill a hole for the gudgeon pin. Whoops, lost my plastic one. And it's going to be a bit tricky. It's not a very big end mill. So going by my last little 2mm one, they break quite easy. So I have a 3mm hole drilled at the right depth for it, and I won't be taking a big cut. I'll be just slicing. I'm gonna slice down this way. I'll use that line to set it up, and I'll cut across here because I need that for the gudgeon pin hole guide. That center line, and the gudgeon pin's probably gonna be a bit of this spring steel I have. It's 2mm. I'm not sure if I should just do a 1.5mm hole on one side of the piston and then heat it up and force it in there so it locks in, because it may rub against the bore if we don't hold it in place. Either that, or in the con rod, I could heat the con rod up and use it to shrink fit onto the, but the con rod, this can pivot in the hole, I guess, and the con rod can just be solid. I'm not sure. Or I could just squash the ends of the pin a slight bit and then it won't come out. I could flare it maybe. I'm not sure how that's going to work either. Being spring steel, it's a bit harder. So I'll set that up and get ready. Okay, I've set the center line vertically. So we're going to be moving across in the horizontal direction to cut the slit. Okay, here goes. Can't really see how far I'm going over on both sides. I wonder if I should just snip the whole side out. I need to set my DROs up, but I think they're flat. They're doing that. But all of them. This one won't even come on. Don't get long life out of them. So I'll wait, I think, and Might have to go to the shop and get some batteries for them, because I can't see down in there to like gauge how much I've even moved. I have cut some of it, like a smidgen. Really hard to see in there. It'd be easier if I take the whole side of the piston out, but will that matter? Normal ones with car pistons and stuff, they're taking out the sides, but they have rings as well. Think about it. Alrighty, got our first piston cut in the center. Oh, does it look center? My eyeballs aren't looking good. Oh yeah, it is. It's just a black texture mark. I'll put my glasses on. And there's a tiny little conrod for it. I gotta clean them up a bit. I just, the whole centers are bright, but the shape is just freehand. And that will slip right in there. We gotta drill it and pin it. It would have been better if it was bigger. This is like, I can't even barely hold on to the thing when I'm grinding. What I ended up doing is center line. I marked each end. The other marks are here. Only travels from the center about 3 mil that way and 3 mil that way. That worked. Now I just got to do 4 more. It took around about 40 minutes, I think. I'm guessing on the time, but it's now after 2:30. I take it all the way to about there. Got a notch. The travel distances here. So once that line hits right there, it's the right depth. That's good enough for now, and good enough for that piston, because it only really needs clearance depth, and then I will position this based on the end of the piston, or that top of the piston back this way for the hole. I was using this as a guide. That's my spare end mill for the job. Hopefully I don't need it. But it's in good condition still. Still pretty sharp. I was only cutting like 1/100th of a millimeter probably, not even that. I was barely turning this, it was only like that much. That's not a lot, but you could feel it cutting, so it made it. And I was at 780 RPM, which seemed to be okay. I'm still not sure with the RPMs and everything yet. The little 3 mil end mill did a wonderful job. I was able to take 0.02 of a mil of a cut deep and reduce the time from 45 minutes on the first one to 15 minutes on the remaining ones. Now I'm gonna have to set it up like that to drill the hole through that center line. But unfortunately, the collet chuck, the smallest collet is 2 and 3 mil, so it won't hold the 1.5. So I'm going to have to use the chuck to hold this little beast. I'm going to try a 1.5 hole in just a bit of scrap steel, around about the same thickness, 3 mil. And I'm going to get the heat gun and heat it up and see if I can expand one side to expand it to 2 mil so it can close down and wedge it so the pin doesn't rock inside the bore. So one side's going to be 2 mil and one side's going to be 1.5, if it works. Or if it has to be 2 mil, I don't know what I'm going to do there. I could probably put a bit of JB Weld in there and just let it set, maybe. That could be an idea. A lot less hassle. That should set around the pin and stop it from falling off. Doesn't really matter. I'll try the heat thing first, because I've only got 1.5 or 2 millimeters. That's 2 millimeter wire. Well, the idea of heat shrinking the or heating the hole up so it enlarges does not enlarge that much for the rod to go into a 1.5 mil. So it looks like it's going to be JB welds jammed into the ends of the pistons once I drill the holes, just to hold the rod. But that will be better than nothing. JB weld's good for heat as well, so it's not going to get past 1,000 degrees. I think it even does more of a temperature than that. I'll read the container. Let's have a look. Right, so JB Weld exhaust is high heat, but JB Weld normal one is only 149 degrees Celsius. But apparently it turns out saturated steam at 50 psi is 149. Superheated steam at 50 psi can go up higher, but I'm not sure how superheated my steam is. It comes out clear, so probably pretty super. So then it's got to travel down a pipe which is probably going to be about 2 meters long, so it's going to lose some of that superheated. It may work in the piston just to hold the thing in there. Either way, it should just hold it. Maybe it melts and then sticks to the side and gunks up the whole cylinder. What to do? But you can't have that thing floating around. It will scrape up and down the bore. Bugger. You can't make a little clip. It's just too tiny to even do a clip. So I'm going to have to go with the JB Weld. We'll see how it goes. Most likely it doesn't even hit super steam anyway. Right, what I think I might do to attach the conrods to the piston is I have 5 of these 2 millimeter socket heads left. It would just sort of fit. I might have to even grind a bit of the socket head off because it will be almost too thin in there for a fit. Yeah, it's going to be close. And how deep that hole is. I can probably lose a millimeter or 2 off the top. I think that's a better option, especially if I want to get the piston out of there. All the pistons and gudgeon pins are in. There was a simpler way. There wasn't enough material on the actual piston to take that 2 millimeter bolt. So what I ended up doing was using the spring steel 2 millimeter pins. I gave them a slight bend. That was too much of a bend. So was that one. And one what got away and then I found it again. They were flying off, cutting them with the bolt cutters. So slight little bend, and they sit in there and they won't fall out at all. I've been wiggling them around. So they sit nice. Why is that focusing? I've didn't number that one because you didn't need to number them all. Put little center mark punch holes at the top of the pistons because I had to machine the balls per cylinder piston. Not going to get that in there by one-handed, I guess. Right, next job will be, oh yes, got one more job left. That's the 25-degree hole from the cam for the air inlets for these. I'll do that at a later date. The last part of the job is to drill the steam hole through the crank shaft. Now, the crank has to be 25 degrees from the inlet hole. So I thought I'd just bolt it up to this, rotate this 25 degrees from the center, and I can just drill straight down the existing hole, and that sets all the levels. Perfect. So I'll just drill that out. And should be good. I have to make a some sort of attachment to a 1/2-inch pipe from this bolt thread, which has already got the center drilled out. Steam inlet drilled out. See it? It lines up to all of the holes, which is perfect. Oh, fuck it. Still have to make the little elbows and stuff, and be it unwise or wise, I'm going to cold glue everything so it doesn't rust, because these will rust out in no time, especially in the pistons. One day of not using it, they won't be moving. So I'm figuring cold gluing. I did that with cold glue, and it's quite smooth, and it hasn't rusted all this time. So it will give a protective coating. It may make the pistons tired, but I think it etches the surface, and that means it removes stuff. So it's only going to be a light coating, so it's probably going to be like that color, and that will probably protect everything pretty much. So I don't know how that's going to react, but if I don't put it on there, it will be alright just on the faces. Probably in there, I don't know. In there's blackened from welding, so that might even be coated and protected anyway from rust. It will just be that surface down there, which won't matter because that brass bush is 1 millimeter protruding from that surface. And figured might as well, instead of having that whole surface be drag, I'll just have that brass bush sitting on the back of that flange. Oh yeah, and I have to make some sort of stand which attaches to this part to hold it up. Just an angle bracket, I think, and something which is going to screw under here and attach to a 12mm copper pipe. There's actually one more job I forgot. The exhaust ports need to be drilled into the cylinders. Test fitting the engine now. Got everything running smoothly, doing an air test. I have to blow it into the back of the ports. I haven't got the tubes and anything set up yet. That'll be the last job for the tubes. So I'll just blow it into each separate one. It should move. Oh, wrong one, this one. So air does move it, so that's a good sign. Getting ready to rust blue the parts to stop it from rusting. I hope shouldn't damage it too badly. So it's 4 cupfuls, just a standard drink bottle cupful of hydrogen peroxide, just the shelf stuff, 3% I think. 1 cup of vinegar and a cup of salt. And then what you do is paint these parts, let them dry, and then submerge them in boiling water until they turn black. You can repeat it many times, but I'm only going to do it once. I think should be enough coating. I coated the milling attachment base for the mini lathe with just 1 coating, and that hasn't rusted and it's nice and smooth. Well, once the coating's all dry and your water's boiling, you just have to dump them in. And you'll see that they're slowly going to turn black. And then you take them out of there and scrub them with steel wool. Leave them for about 15 minutes or so. Shouldn't warp them too much. It's only like boiling water. Stick the lid on. Keep the temperature high. Probably only going to do it 1 coating. Right, I'll clean them up in a minute. Alright, this is just 1 coating after using fine steel wool to clean them off with. It's come up quite good. I'm happy with that coating. Haven't tried if the pistons fit and stuff yet. But after you do that, I soak them in some oil for a little bit. Piston. If you wanted black, you would coat them a couple of times if you want. But I think that should be enough coating. That's the end cap. See how it's not even. So you'd scrub it off, recoat it with the peroxide paste, and do it again and repeat until you can get your desired darkness. So I just got it in engine oil now. Doesn't really matter. So hopefully it fits together. Bending the steam input pipes. They need to be 90. They turn out like this. Right, ready for a test. I've just put the pipes in. I haven't soldered them or anything. I'm going to try with compressed air, 80 psi, that runs better than the plastic version of this thing. Didn't even have to turn it, it self-started. Let's see if that does it again. Well, it must have been a fluke. Oh no, that's only half throttle. Not a bad run. So I probably don't have to weld or solder. I was going to solder the tops, but if I solder the bottoms, I'd have to always heat it up to get it out of there if I need to do anything. So for now, I'll leave it as is. So I've got the end plate. I want to Loctite that screw. The center cam thing with that offset hacksaw mark through it. It looked pretty balanced. I'm going to check the camera to see actually how balanced the thing is. Just check it again, see what the compressor's at now. So it's about 40 psi. The plastic version needed the whole 80 to work, and it wasn't getting that fast. So now, because it's half drained out, it's only a small compressor. It's at 40 and dropping. So the steam boiler does 50. I think we'll be able to run this. I'm gonna do a 3D printed generator as well for it, and I have to wait till it gets to really cool weather for the boiler to be ran.